Okay, so if you remember from Algebra 2 last year, when you're adding fractions, you need a common denominator. So we're going to take this denominator, and we're going to multiply it by x minus 3. What will we do to the bottom? We have to do to the top. And we do the same thing over here. So this fraction, we need an x plus 2 to get a common denominator. And what you do to the bottom, you have to do to the top. Okay, so then when we are adding fractions, we write the common denominator. And then what I'm going to do is I'm going to take that first numerator. I will distribute the x minus 3. And then I'm going to take the second numerator, and I'm going to distribute the x plus 2. Okay, so that's going to give me 3x minus 9 plus 4x plus 8. And that's all going to be over x plus 2 and x minus 3. And let's go one step further, and let's simplify and add like terms. So we're going to get 7x minus 1 all over x plus 2 times x minus 3. Okay, so when we are adding two fractions and the denominators are not the same, we found a common denominator. But in doing so, we had to multiply numerator and denominator by a factor, and the same thing over here. We brought down the common denominator, simplified the numerator, and this is our answer with our common denominator. Okay, now I want you to take special note. Look at this carefully. And now turn the page. Make sure you're taking notes, okay? And turn the page and look at this. So now, if you look at what we just did, do you see that this numerator matches the numerator that we got in the last question? The only thing that looks different is the denominator, but we don't need to worry about that because watch. So this matches the numerator we got as an answer. And if we take that denominator and we factor it, now go back and look at our answer, okay? And you will see that this is the answer that we just got. So what we're going to do is something called decomposing. Okay, so it's decomposition of fractions. So basically what we're going to do is we're going to take this equation, or this expression, I should say, this fraction, and we're going to go backwards. So we're going to end up with what we started with on that first question on the previous page. Okay, so we're just working backwards now. All right, so what we do is, our first step is going to be to do what we just did. So we always take this, if it's not factored, and we factor it, okay? So then what we're going to do is we're just going to write that down. So we're going to write 7x minus 1, and we're going to put it over x minus 3 and x plus 2. Okay, and as you can see from the previous page, we ended up having two fractions and we were finding common denominators. So what we're going to do is we're going to set this equal to two fractions. One is going to have one part of the common denominator, and the other one is going to have the other part. Now it doesn't matter what order you put these two in, so I could have put the x plus 2 here and I could have put the x minus 3 here. That doesn't matter. So what you do is once you have your factors of your denominator, you put one under one fraction and you put the other under the other. Now, we don't really know what goes in the numerator. I mean, we could cheat and look at the previous page, but for future questions, we're really not going to know that. So what we do is we just call it A, and then we'll call this one B. Okay, and that's what we're essentially trying to figure out, is what we started with. And so once we find out what A is, we're going to plug it in here, and once we find out what B is, we're going to plug it in here, and that would be our answer. Okay, so the way we go about this, though, is we are going to look at this as a fractional equation and look at the common denominator. So the common denominator for all three fractions would be x minus 3 and x plus 2. Right? So what we're going to do is we are going to I'm going to have to write it up here because I can't fit it, but I'm going to multiply this entire thing in brackets by x minus 3 and x plus 2. Okay, you should really have it here, but I just can't fit it. So if I multiply this first fraction by x minus 3 times x plus 2, you should see that this is technically in the numerator, this is in the denominator. They will cancel each other out, and we're just going to be left with 7x minus 1. Okay, let's go to the second term. So this is in the denominator. These guys are technically in the numerator. Do you see that we're going to have x minus 3 in the numerator cancel with x minus 3 in the denominator? So we'll be left with this a and this x plus 2. Okay, so we're just going to write down a, and then we're going to write down x plus 2. Okay, then next we're going to do the same thing again. So we're multiplying this fraction. There's an x plus 2 in the denominator. Remember, these guys are technically in the numerator, so this x plus 2 and this x plus 2 will cancel each other out. And that's going to leave us with the b and the x minus 3. So now we have an equation that no longer has fractions in it, which makes life a little bit easier. Okay, now what we're trying to do is we're trying to find out what a and b are. So the way we kind of go about this is we're going to pick a number that we're going to substitute in for all of our x values. Okay, and the easiest way to do this is to pick a number that makes either this denominator or this denominator equal to 0. And maybe that doesn't make sense. Hold on a second, I'll explain. So I'm going to start with, I know that if I put a 3 in here, that will make this denominator equal to 0. Okay, so I'm going to start by saying x is going to equal 3. I'm going to box that off. Okay, now there's a reason why I'm doing this, so watch what happens. So I'm going to plug it in right here, and I'm going to plug it in here, and I'm going to plug it in here. Everywhere I see an x, I'm going to put in 3. Okay, so I'm going to start with 7 times 3 minus 1 equals a. Now, there I see an x, so I'm going to put in 3 plus 2 plus b times, I see an x, I'm going to put in 3 minus 3. Do you see that right here, this is going to cancel out, which actually will make it easy for us. We want that to happen, so that way we can figure out what a is. Okay, so on the left-hand side here, I'm going to have 21 minus 1, which is just 20, equals 5a, and now you can see that a is 4. Okay, so that's why we choose a number that makes the denominator equal to 0, because then it gives us the ability to cancel out one of the letters so that we can solve for the other one easier. Okay, so now we're going to do the same thing again. Here we picked x equals 3 because I knew that this would be 0. Now I'm going to pick x equals negative 2. Okay, again, just because it makes our life easier. All right, so let's go down, and we're going to say x equals negative 2. All right, so we're going to do the same thing we did before. We're always going to go back to this original equation right here. And actually, you know what? Let me just box that off so you can see this is the equation that we're going to go back to and plug these x values into here to help solve. Okay, so let me go back to my black ink. So I'm going to do 7 times negative 2 minus 1 equals a times negative 2 plus 2 plus b times negative 2 minus 3. Okay, and hopefully that you see here rather that this is going to cancel out. In the future, you don't need to write this, and you don't need to write this, but I'm just writing it for the first time just so that you kind of see where I'm getting everything from. That's going to cancel out. So on the left over here, I've got negative 14 minus 1, which is negative 15. equals, and on the right I have negative 5b. So then you can see that b is equal to positive 3. Okay, and believe it or not, we kind of have our answer here. So I am going to squeeze it in here. You should be taking notes in your packet. And so what you're going to do is you're going to write 7x minus 1 over, and let's put the original equation that they gave you, or the original expression, I should say. There we go. And now we know it's equal to, let me just show you what I'm doing. So I'm taking this, right, but we want to use the original expression. And now all I'm going to do is replace my a here and my b here, and that's my answer. Okay, so my a is 3, right? So I'm going to have 3 over x minus 3. All right, just a quick thing here. I have plus, but notice that, oh, never mind. I'm not going to say it because it's not the case in this one. We'll discuss it in class. Okay, so getting back to it, then I have plus, and my b is 3 over x plus 2. And oops, on me, I made a mistake, right? A is 4, so this right here should be a 4. Sorry, my apologies. And there's your answer. Now, if you go and you look back at the previous page, you look at this, okay, this is the expression that we started with, and this is what we ended up getting. And what we did with this question was we started with this, and this is what we ended up getting. Okay, so our final answer is what's in that black box. So when we decompose, like I said, we're just going backwards, and we're figuring out the two original fractions that we would have had to then, go through, find a common denominator, and simplify. Okay, so normally you're used to starting with this and ending with this. Now we're just going the other way. All right, let's turn the page and look at the next question. We're going to look at number 2. All right, so we're going to do the same exact thing that we did on the last one. I would suggest, obviously, that so we can figure out what our denominator is going to be, let's take a second here. And we're just going to keep our numerator, and we are going to factor our denominator. Okay, so then what we end up doing then is, so we have x minus 1 over, let's just write the factored form of that denominator. Okay, so what we're looking for is two fractions that are going to add together. Essentially, we want to figure out what these two fractions are here that are going to add and give us this as our answer. So when we write our factored form of the denominator, we're going to put one of the factors here and the other one here. Doesn't matter what order. So I'm going to put the x here, and I'm going to put the x plus 1 here. Okay, I don't know what the numerator is yet, and I don't know what that numerator is yet either. Okay, so then from here, we're going to multiply that entire thing inside the brackets, technically by x times x plus 1, the common denominator. That's what we're multiplying it by, and technically it's over 1. So if I multiply this fraction by this, you should see that this and this cancel each other out. Okay, and just leaving me strictly with just x minus 1. All right, let's look at the second fraction. So then we have this one. This is getting multiplied by this, so you should see that the monomial terms of x disappear. And then we're just left with a and the x plus 1. Okay, and last, we're going to multiply this last fraction here times this. So the x plus 1s are going to cancel out, and we're just going to be left with b and x. So b and x. All right, at this point, this is when we start picking numbers to plug in. So what we do is we look at the denominator. I'm going to choose x equals 0 because that's what would make this denominator 0. And I'm also going to choose x equals negative 1 because that's what would make this denominator equal to 0. It doesn't matter which one you choose first, so you can do whatever you want. I'm going to go with 0 first. Always write down what it is you're choosing, like I just did in the green box. Okay, so then I'm going to do 0 minus 1, oh, hold on a second. Let me also reiterate, remember we're always plugging everything in to this equation right here. So I'm going to be plugging in 0 here, be plugging in 0 here, I'm going to be plugging 0 there. Okay. So that's going to give me negative 1 on the left, and then I've got a times 0 plus 1. Now, I am not going to write anything here because I know x is 0. We cancel that all out. And we're going to get negative 1 equals a. And that's it, right? Okay, so now let's go to the next value of x. So I'm going to plug in x equals negative 1. Again, the reason why I'm choosing negative 1 here is because it makes this denominator equal to 0. All right, so if I plug in negative 1, and remember, I'm always plugging it into this equation, I'm going to get negative 1 minus 1 equals, now if I plug in a negative 1 here, this whole thing is going to be 0, so I'm not going to even write that down. I'm just going to plug the negative 1 right there. And if I do that, that's going to give me b times negative 1. So that gives me negative 2 equals negative b. So then, therefore, b has to be 2. Okay, so we pretty much have our answer here. So I'm going to rewrite the original equation, which is x minus 1 over x squared plus x equals, and then I'm going to go right back here, and I'm going to plug in my new a, and I'm going to plug in my new b, and then I've got my answer. All right, so my a is a negative 1, so I'm going to put negative 1 over x, and my b is a 2 over x plus 1. And there's your answer. And that's it. Now you can, just so you know, these guys can be in opposite order. Like you might have this guy here, and then this one here. That's totally fine.